Now we're going to talk about looking at the difference between these two groups with hypothesis tests and randomization. In this video, we're going to do hypothesis tests. And remember, we're looking at proportions in two independent groups. So the hypothesis sets, like we had before for one group, we have left one-tailed, right one-tailed, and looking either way, two-tailed. And so you might remember, just as a comparison, that we had like HO, we said rho is, let's do the easy one, rho is equal to some number, right? So that represents a number. And then the alternate would be rho is not equal to some number, okay? So this is for one group. Here we have two groups and they both have their own proportions. And so instead of comparing, let's do the two-tailed over here. Instead of comparing a row to a number, we're comparing row for the first group to row for the second group. So the null hypothesis here is that the two groups have equal proportions of whatever we're interested in. And the alternate hypothesis is that they are not equal in either direction. One could be bigger than two, or two could be bigger than one, okay? For the left-tailed, one-tailed, we're putting in the alternate that row one is less than row two. So notice the arrow is pointing to the left. And so that means that we are looking for a negative difference. So row one is less than row two, means that row one minus row two would be less than 0. And that's actually another way that you can write that hypothesis. HA would be that. HO would be row one minus row two greater than or equal to 0. Okay, so you can do it that way, and that might make more sense to you in terms of thinking about the fact that we're looking at a difference. For the one-tailed to the right, then we're saying row one we think might be greater than row two. So when we take row one minus row two, we're going to get a positive number, which means we're looking out in the right-hand tail. And again, the opposite of it always goes in the null. And notice that the equals part is always in the null as well, okay? So what is the set of hypotheses to test whether soccer and football players have different rates of knee injuries? So remember, different is a two-tailed type of language, okay? So HO and HA. Okay, so we have a null and we have an alternate. And here we have a proportion for soccer and we have a proportion for football. And that's what we're comparing. And so different, they could be different in either direction. So they're either equal to one another or they're not equal to one another. And again, you could also write these P soccer minus P football equals 0, or row, sorry. Row, see, it's easy to do that. Row soccer minus row football is not equal to 0. Notice that for the two-tailed, it doesn't really matter which one's first and which one's second, but for one-taileds, it does, and you want to do the subtraction in the same order that they are in your hypotheses, right? So left to right. So ours would have to be soccer minus football. Just pay attention to that when you're doing one-tailed. Okay, so method one, doing the hypothesis test using the formula. And since our hypotheses all assume that the proportions are equal, the equal part always goes in the null, we can use a pooled estimator of the proportion now. And we talked about this before, back when we were talking about confidence intervals and ways to think about that. So we took the total number of successes, which sadly in this case is injuries, over the total number of both groups. If you don't have the number of injuries, then you can take the group size times the proportion for that group, and then add the second group size times the proportion for that group, and then divide them by the total. Okay. And then that forms this thing called p hat, which is a pooled estimate. And then we have z is the difference between the two proportions in the sample. So sample proportion 1 minus sample proportion 2, divided by the standard error, which is p hat times 1 minus p hat times 1 over n1 plus 1 over n2. Okay, these formulas are kind of long. So in R, this is actually pretty easy because there's this thing called prop test. And so what you do need for that is you need to know how many successes in each group. So you need that x1 and x2. Okay, so then you say prop test x is a vector of the success numbers in each group, and then n is a vector of the totals in each group. And you just run that, and it will give you a z-score. It actually gives you a chi-squared, and the chi-squared looks like that in the output. That's how it's denoted. And to get the z, you have to take the square root of that. And then it also will give you the p-value, and the p-value is the same for the chi-squared and for the z. So the p-value it gives you is 0.0339. That is less than 0.05, and so we would be likely to say the groups are significantly different. If we want to work out the formula by hand, then here are the incidence rates, 92 and 88, which is 180 times 0.51 plus 220 times 0.4, all over 180 plus 220, which is the 45 pooled estimate that we looked at before. And then z is the difference, and remember that's the same as the point estimate we got for the confidence interval, divided by 0.45 times 1 minus 0.45 times 1 over 180 plus 1 over 220. And that gives us a z of 2.20, which is slightly larger because we're doing some rounding that it's not doing. And a larger z gives you a slightly smaller p-value. And so the p-value here is 0.028, which is still less than 0.05. But this is a little bit less conservative because of the rounding. If you want the p-value here, you need to, because it's a positive score and we're doing a two-tailed test, so we're going to have to multiply it by 2. And because it's a positive number, we're going to have to do 1 minus p-norm of that number. So this part gives us the tail probability, and then we multiply that by 2. And that's it for our hypothesis test approach.